Inventory control. Inventory control is nothing but the quantity stored to meet future demand or sudden demands. It's called inventory. Inventory is nothing but storage. So inventory is required to meet anticipated demand. One thing, inventory helps us against stock out of situations. Inventory also ensures smooth flow of production process. So it helps against stock stock out situation. Whenever there is a material is out of stock, then if you have inventory of that material, then it helps. It ensures smooth flow of production process. So inventory, there are, if you want to store the material, you need to spend money on that. So what are the costs incurred in inventory? These are called inventory costs. In inventory models, various cost elements are considered, and generally these costs are depend upon the timing and quantity to order. The different costs relevant to inventory models are, like first one is unit cost. Unit cost of inventory. So unit cost is nothing but the price of the item. Price which is said to be supplier for the procuring 1 unit of inventory. Price of 1 unit of item. For parts manufactured in-house, cost of inventory is the direct management cost. Okay. Ordering cost. It's also called or setup cost. Ordering cost is the cost associated for placing an order. So that is called ordering cost. For one order, how much price we need to pay. That is ordering cost. The expenses incurred in the purchase department and its main constituent setup cost is used when inventory is made within the organization. Unit cost, ordering cost, and holding cost or carrying cost. So holding or carrying cost occur due to the maintaining an inventory level in the organization due to the interest on the held up capital in the inventory. It's also called carrying cost. The inventory and for storage cost all comes under holding or carrying cost. Shortage and stock out cost. So starter cost is a cost incurred due to stock out situation. You may lose goodwill of the employee also. Sorry, goodwill of customer. So variables in inventory models, these are important. So there are few variables. Q is the ordering quantity. So each textbook has their own notations, and you can also, you follow whatever you studied. D equal to annual demand. C is the cost of inventory per unit item. So C or P. P is the price or unit cost. So next one is carrying cost. So C1 is equal to holding or carrying cost. It also expressed sometimes in terms of percentage of unit cost. It has X percentage of P. Next cost is ordering cost. Ordering cost per order. R is a reorder point. So TC is nothing but total cost. TL is lead time. C2 is shortage cost. So these are the variable names which we use in inventory models. The first inventory model is assumptions of the first inventory model. This is also called Wilson's model, economic order quantity model. Model 1, Wilson's model, or EOQ model, economic order quantity. In this are main assumptions. So uniform demand. Uniform demand is uniform. The ordering cost and inventory carrying cost are all constant. Shortages are not permitted. So replenishment is instantaneous. This production rate, instantaneous production rate. Here that is lead time is 0. So if we look at the diagram, so instantaneous demand. So once the stock is over, suddenly you will get the replenishment is instantaneous. Suddenly you will get the quantity. So this means lead time means placing an order and receiving the stock. It's 0. That means suddenly you will get the replenishment, instantaneous replenishment. Shortages. There are no shortages. So this economic order quantity maximum inventory level is Q and minimum is 0. So demand is, if you look at the diagram, it is initially it is Q. It is a maximum inventory. I'm sorry, maximum. You have quantity with you. So as a demand uniformly it is coming down. And once it reaches zero, once all quantities will over, suddenly the entire store will be filled. Again, once it will over, again it will fill like that. It is not ideal situation. It is ideal situation. It is not actual practice. In actual, you will have shortages. This line comes down to the x-axis. If it below the line comes below the x-axis, that means negative values also considered. Shortages are considered. So annual demand equal to D units. Ordering quantity equal to Q. So number of orders equal to D by Q. And ordering cost per order equal to C3. So total ordering cost equal to C3 into D by Q. So this is one equation, ordering cost. So next, average inventory. So if you look at the diagram, there are inventories maximum and minimum. Maximum is Q, minimum is 0. So maximum minimum by average we have, because the inventory varies continuously. So storage cost varies. So that's why instead of that we take average value. So cost per unit or storage cost equal to C1. So next, average inventory cost equal to Q by 2 into C2 is 1, or this can you express it in terms of P into I. So P is the price of an item and I is the percentage of the price of the item, that cost. So it can be expressed as like 20% of the price of the item is a storage cost. So total variable cost, because we have not considered the shortages, so that's why shortage cost will be 0. So total variable cost is equal to PVC equal to ordering cost plus inventory carrying cost. So total variable cost equal to ordering cost is D by Q into C3 plus inventory carrying cost Q by 2 into C2, or this we can write PI also, that anyway we have already explained. So fixed cost. So first we will complete this, then we can calculate. So total variable cost equal to that one. It is a function of Q. So if dt by dq equal to 0, so minus d by dc3 by q square plus root 2 dc3 by c1. Sorry, this is not c2, c1. Please correct it. C2 is shortage cost. Correct in earlier page also. This is C1. C1 is ordering cost. So you have to remember economic order quantity. It is called EOQ. Oh, sorry. EOQ. So economic order quantity Q equal to 2dC3 by C1. So this is for first case where no shortages and instantaneous replenishment and uniform demand. So next case, in that same case, we know the economic order quantity. So what is the total variable cost at economic order quantity? Substitute this EOQ value in the total variable cost. D by Q into C3 plus Q by 2 into C1. Substitute Q equal to root of 2d3 by C1. So then you will get dC3 by 2dC3 by C1 plus 2dC3 by C1 by 2C1. So simplifying, the value you will get is 2dC3C1 or 2dC3P into I. Total variable cost at economic order quantity. So if you draw the diagram, economic order quantity, so Q, as Q increases, the cost, number of orders, if you know what will happen, the ordering cost, what will happen the carrying cost. So this is shown with a chart. This is also important, they asked once in GATE the same chart. So they have given chart like this. So this is called, wherever it is minimum EOQ, economic order quantity, and this one is as a number of ordering quantity, as quantity increases, number of orders decreases. So ordering cost decreases, OC or ordering cost is equal C3. So this line is straight line as a number of quantity, the quantity ordering quantity increases, carrying cost increases. It's directly proportional. So C1 or carrying cost. This is total variable cost. So this, sorry, here y axis is not Q, y axis cost. So 2 marks question they asked in GATE by giving the same diagram and what is ordering cost and what this line represents and what and the straight line represents passing through diagonal. That's for simple. So for variable cost, the above minimum variable cost, there where the there are two points also may possible. Suppose if you have take the point, if you take a point here, another point here, so variable cost is same corresponding to the 2 points. So these points are called Q1 and Q2. So economic order quantity lies between the Q1 and Q2. So total variable cost is same, but economic order quantity is different. Total variable cost of Q1 equal to total variable cost of Q2. So economic order quantity is different. So there is one relation, economic order quantity equal to root Q1 into Q2. If you know the any 2 points on that line which is having same cost, then economic order quantity is equal to root of Q1 into Q2. At economic order quantity, ordering cost is equal to the carrying cost, right? That's also one point. Total variable cost at economic order quantity, ordering cost equal to inventory carrying cost. So total variable cost economic order quantity equal to 2 inventory carrying cost or 2 times of ordering cost. So there are so many equations we can get from this. So next is total annual cost. Sorry, we got the variable cost. Similar way, what is the annual cost? So for annual cost, we need to add the fixed cost. Total annual cost is per cost per any quantity, for quantity Q or equal to P into what is the demand, number of quantity, annual demand is the D by Q into C3 plus Q by 2 into C1. So that is total annual cost at any quantity. Total annual cost at economic order quantity equal to P into D plus 2AD C3 C1. So total annual cost at economic order quantity is this one. So we got the total variable cost plus fixed cost per annum. So that is the total annual cost of economic order quantity. Sometimes what happens is customer offers discount. Sometimes customers offer discount. So then what will happen to the economic order quantity? Suppose if quantity Q1 is order of R1%, then check the value total annual cost. Total annual cost of Q1 is equal to at R1 percentage discount. At R1 percentage discount, we know P into D is fixed cost. In that discount is 1 minus R1 by 100 plus D by Q into C3 plus Q by 2 into C1 into 1 minus R1 by 100. So 1 minus R1 means that much we are paying. R1 is a discount. So remove the discount. This is the cost we need to pay. So calculate this value and calculate the economic order quantity. Calculate total annual cost at EOQ and total annual cost at Q1 with discount R1. Whichever is minimum, take that quantity. Order that one. So our objective is to order such that the cost has to be minimum. Next is we have understood the first model. This is the first model, and there is one sensitivity of the EOQ model, basic model. Sensitivity of EOQ model. Sensitivity of EOQ model. So sensitivity is defined as total variable cost at any quantity divided by total variable cost at economic order quantity. So total variable cost at any quantity is D by Q into C3 plus Q by 2 into C1 divided by 2D C3 C1. After simplifying, you will get Q by EOQ plus EOQ by Q. So EOQ is nothing but here EOQ equal to 2dC3 by C1. So this is the sensitivity of EOQ model. Similarly, so next is Optimum ordering interval. We know optimum order quantity. Optimum ordering interval. So that is nothing but T. T equal to, normally it is D by Q for normal quantity. T for EOQ equal to D by EOQ. Optimum ordering interval, the interval between two orders. So optimum number of orders. N. It is called N star. You can keep some difference. So N generally equal to Q by D. Oh, small correction. So optimum ordering interval is Q by D. It is reverse. This one is, so this one is Q by D. Q by economic order quantity by so economic order quantity by D. So Q by D is, you will get D because D is in units is. So here EOQ by T. T is annual demand. So demand number of units per year. So here N equal to T by Q. So don't, it's slightly confusion here. N equal to D by Q. So N at economic order quantity N star equal to D by EOQ. If you consider economic order quantity, then it is called EOQ. So D by EOQ, we know that 2DC3 by C1. So simplify this and you can get it. Similarly, EOQ is 2DC3 by C1 into 1 by D. So you need to remember more formulae here. Inventory control. So next is lead time.